In this module, I want to discuss significant figures. We're going to have a couple goals. The first is to determine how many significant figures any number has, and then how to determine significant figures when doing arithmetic computations. Okay, so the first is to determine how many significant figures any number has. To do that, there are two rules. So rule 1 is if a decimal point is present, your number of significant figures, I'll just abbreviate number sig figs, is equal to the total number of numbers. So as if you have a decimal point, the total number of numbers you have is the number of significant figures. Okay, so that's easy enough. So rule 2 is what happens if no decimal point. The number of significant figures, is equal to the total number until last non-zero number. Now, most have probably done this before, and if you haven't or don't remember, this is most easily done just by looking at examples. So let's say I have number 32.5940. I have a decimal point. This falls under rule 1. Count up my total number of numbers, 1, 2, 3, 4, 5, 6. So the number of significant figures this number has is 6. Okay, let's look at another number. Let's look at 325,940. Now, this number has no decimal point, so this follows under rule 2. The total number until the last non-zero number. 1, 2, 3, 4, 5. 4 is the last non-zero number, so this number has 5 significant figures. Okay, now let's look at the number 330,000. This has 2 until the last non-zero number, so 2 significant figures. But if I had 330,000.0, now I have a decimal point. This follows under rule 1. I count up the total number of numbers, and I have 7. So that's applying rule number 1 and rule number 2. However, let's say, for example, what happens if you do an experiment and the result of the experiment is 330,000, but 4 of these numbers are significant. I mean, this 0 is significant, and this 0 is significant. How would you represent that? Because if you just wrote 33,000, someone applying the rules would say that there are only 2. And to do that, you have to represent this number in scientific notation. You would represent that as 3.300 times 10 to the 5. This number is now 330,000, but it has a decimal point, and therefore all 4 of the numbers in that figure is, all 4 of them are significant. Okay, so that's the first goal, is how to determine the number of significant figures in a number. Now we want to ask the question, how do we determine the significant figures in computation? There's an important fact that one should know, which is that in science, significance of the result is done through error analysis. You go through and do an experiment, and you have to take careful computation of your systematic and statistical errors, and there's an entire procedure through which that uncertainty propagates through all your various calculations. And we aren't doing that here. And so this whole error analysis is what you learn in the lab component of this class. But since this part is not in the laboratory, we won't be looking at error analysis and error propagation. And so we sort of need a way to deal with significant figures for homework assignments. So what we're about to look into is not rigorous science as much as it's a bookkeeping device to help us keep track of significant figures when we're doing homework problems. Okay, so doing significant figures in computation. Again, we have a couple rules. Rule 1 is that for multiplication or division, the answer has same sig figs as the least known input number. For example, if I have 700 times 956, now if I put that in my calculator is going to give me a number that says 669,200, but all of those values are not significant. So if I go back to my input numbers, this one has 3 significant figures, this one has 1. And so my answer only has the number of significant figures as the least known input, that's 1, and so the answer would be 600,000. That's the number with the correct number of significant figures. Okay, for rule 2, for adding and subtracting, we look not at the number of significant figures, but at the placeholder for the input and the output. So the last significant place value for the answer matches the largest last significant place value of the input. This is one of those cases where the definition is in fact much more complicated than simply doing a couple examples and looking at it. So if I were to add the two numbers 3.522 and 7.12, my calculator would give me 10.642, but this is not all of these values are significant. So the largest last significant place value. So what that means is for the first one, this is the last significant place value, and for the second one, this is the last significant place value. And so here, this 2 is the largest last significant place value of the input, which means this is the last significant place value for the answer. And therefore, the correct answer is 10.64 to the correct significant figures. Now, many books will say that the answer has just the least number of place values. For example, this one has fewer place values than this, and so it would have the answer would have, say, the 3 significant figures. But that doesn't really work here. There are 4 significant figures because you ended up with 10 instead of 7. And so I can do another example that shows that even more dramatically. Let's say I were to add 3.522 to the number 712,081. Well, putting this in my calculator, I would get 712,084.522. Not all those are significant, so if I look at the last significant place value for the first input is there, the last significant place value for the second input is here. This is the largest last significant place value, and that means this is the largest. This should be the last significant place value for the final answer. And so remember, when you eliminate insignificant digits, you always round for your last significant figure. So the answer for this would be 712,085. You don't just truncate, but you round to the nearest significant figure. So the answer to this one has 6 significant figures. And so to identify the number of significant figures, you use the first 2 rules. If the decimal point is present, the number is all of them. And if no decimal point is present, you go to the last non-zero significant digit. And of course, if 0 is your last significant digit, then you have to use scientific notation. To compute significant digits, multiplication and division, the answer has that with the least number, wherein for addition subtraction, you have to find the last significant place value and use the largest one. Now, in many cases, when you're doing homework problems, always assume that the input has as many significant figures as necessary. I mean, sometimes you might have a length of 5 meters. And you should assume that all the input has at least 3 significant figures, so you can do computations. And because sometimes they just don't want to, the book doesn't want to write 5.00 all of the time. So assume, unless instructed otherwise, assume 3 sig figs for input. Always use more than that for internal calculation. If you're doing internal calculations, you want to keep as many significant figures as possible so you don't have rounding error. And then the result should be quoted using the rules, or results should be quoted, will often be given. You will be told to give 2 or 3 significant figures. So always assume that you have at least 3 at the input for the homework problems in the class, and then use the rules or quote the number of significant figures asked. And that's the end of this module.